Hello, I'm Essay, your AI essayist. Please note that all content, audio and video in this presentation are AI generated. As AI can sometimes produce inaccuracies, I encourage you to verify any factual information presented. With that in mind, let's begin.
Augustin-Louis Cauchy's 1,829 exercises of analysis and mathematical physics stands as a monumental contribution to the foundational principles of mathematical rigor. This work, born from the fertile intellectual soil of the early 19th century, profoundly shaped the future trajectory of mathematical analysis and physics. Its impact extends far beyond the specific problems tackled within its pages. It represents a paradigm shift in the very approach to mathematical inquiry. Cauchy's predecessors, notably Euler and Lagrange, had laid the groundwork for the analysis of functions and differential equations. However, their methods often lacked the rigorous, axiomatic structure that Cauchy sought to impose. This absence of precise definitions and careful deductions left crucial gaps in the mathematical edifice. Cauchy's work addresses these shortcomings directly, establishing a new standard for mathematical proof. The core tenets of his analysis revolve around the precise definition of limits, continuity, and the differentiation of functions. These concepts, while seemingly abstract, have demonstrable implications in the physical world. The exercises delve into the intricacies of complex functions, introducing novel techniques for understanding their properties. Cauchy meticulously formulated theorems concerning convergence of series and the behavior of functions under transformations. These theorems, demonstrated with rigorous proofs, serve as exemplars for future generations of mathematicians. The development of the function concept itself, its implications for modeling real-world phenomena, was significantly advanced by Cauchy's work. Specific examples of such analysis include the exploration of Fourier series, the study of trigonometric functions, and the initial steps toward complex analysis. The exercises offer precise definitions of the integral, a foundational concept in calculus, demonstrating how to evaluate integrals rigorously. The nuanced discussion of the integral from a point of view of limit processes was essential for future applications of calculus. The immediate impact of the exercises is readily apparent. The rigorous standards set by Cauchy swiftly influenced the approach of other major mathematicians of the time. Physicists began to leverage these new analytical tools to explore a wider range of problems. For instance, the analysis of oscillations and wave phenomena. Engineers also recognized the practical utility of Cauchy's theoretical structures for solving problems of structures and mechanics. His focus on demonstrable proofs fostered deeper understanding, allowing for the accurate analysis of physical processes while introducing new tools for calculation. Cauchy's innovations paved the way for the development of abstract algebra and topology. Concepts initially introduced in the exercises, such as the ideas of continuity and topological spaces, were subsequently elaborated by mathematicians like Riemann and others, eventually leading to profound advances in both abstract mathematics and its application within physics. For example, Cauchy's rigorous formulations of analysis profoundly influenced the mathematical understanding of heat diffusion. His ideas formed the bedrock of rigorous differential equation modeling, laying the intellectual foundation for the study of complex systems. The reception of Cauchy's work was, predictably, complex. Some contemporary mathematicians found his insistence on absolute precision challenging, preferring the more empirical approaches of earlier generations. However, the growing consensus, borne out by the work of subsequent generations, was undeniable. Cauchy's rigorous methods, while initially met with resistance, became indispensable for scientific progress. His influence is evident in the subsequent works of numerous leading physicists. His ideas impacted, for example, the evolution of fluid mechanics. In dissecting the genesis of the exercises, we find significant influences from Cauchy's own earlier work. His extensive exploration of the calculus of residues, for example, lay a groundwork for solving specific types of complex integration problems. The development of specific mathematical techniques was also crucial to this analysis. The specific influence of Cauchy is unmistakable, especially in the transition to a more rigorous, axiomatic approach. Directly influenced by Cauchy's work, a host of mathematicians explored and extended the concepts he outlined. For instance, the work of Riemann directly built upon Cauchy's formulations, extending the theory of complex analysis and paving the way for the development of complex variable functions. Further, this work offered invaluable insight into the nature of differential equations, enabling the mathematical analysis of dynamic systems. The 1,829 exercises of analysis and mathematical physics served as the springboard for deeper, more generalized analysis. In conclusion, Cauchy's 1829 exercises represents a watershed moment in the history of mathematics. Its rigorous approach, insistence on precise definitions, and emphasis on demonstrable proofs established a new paradigm for mathematical inquiry. This work's impact reverberates through the corridors of mathematics and physics to the present day, shaping the very way we approach these fields. His dedication to absolute precision was not merely a nicety, it was a revolutionary approach that fundamentally changed the landscape of mathematical analysis. This work is absolutely a defining moment, a cornerstone of mathematical rigor.
We really appreciate you tuning into this AI-powered presentation. Our goal is to push the boundaries of AI in content creation, and your input is invaluable. If there's a particular subject you'd like to see us tackle next, or if you have suggestions on how we could fine-tune our AI's creative prompts, please don't hesitate to leave your ideas in the comments section. We're excited to bring you more unique content very soon.